We're looking at this post from dirtdiverfpv, and thank you, Dirt Diver, for giving us a video to look at. Always nice to see copters flying instead of just lines on a page. When is too much gyro filtering? Do I have enough? We'll look at that, no problem. Is my P too low? P roll specifically seems quite low, but I get oscillations otherwise. If you get oscillations, P is too high. I agree. Your P on roll is 0.5. Welcome to the world of LuxFloat, my friend. Especially if you have a high-powered or high-ish powered system. Those numbers get crazy low, and it's shocking. If you have the it's 0.500. If you have the new GUI that Boris came up with that lets you have 3 decimal points instead of just one, so you could have 0.512 instead of zero point 0.5, full stop. That might be helpful in your tuning, but if you get oscillations, and if you look in the black box trace at your P, your roll P and your roll gyro, and you see oscillations, P needs to come down, unless you got something crazy like your your flight controller is not bolted down solid, or you got an arm loose, or you got a motor with a bent shaft or something, something crazy like that. Let the flight characteristics dictate the tune. Don't get hung up on the numbers. I mean, the numbers, if you show me a copter with LuxFloat with a P gain of 6, I'm going to laugh at you and tell you you're crazy, right? I mean, so there's a range, right? But if there's clear flight performance that's dictating something, then you gotta go with it. Bounce back at the ends of rolls. So I looked at your tuning, your PIDs before I got started this video, and I do see your D on roll is 15 and your D on pitch is 25. It's probable that those could be higher. Back in the day before we had soft filters and the low pass filter on D, we couldn't turn D up very high without amplifying noise unacceptably. Now we can. So these numbers, just my gut feeling is that those are going to turn out to be lower than they need to be, especially roll. So, get those up there. Let's take a look though. So the first thing I got to do is I got to align the trace with the video, and it's one of those things that I might do behind the scenes, but I figured, let's show it. Who knows? Maybe people will go, oh, hey, that's how you do that? I don't know. So the first thing I do is I set the playback speed to 300, and I make sure my volume is turned up on my computer. I'll try and turn it up so my microphone picks it up so you can hear it too. And I'm going to go back to the beginning of the video, and I'm going to play. And I'm going to wait for the moment when the motors first start. Now I'm going to go back to 50%, and I'm going to rewind it a little bit, and I'm going to do it again. Okay. Now see, we're lucky here because we actually have the arming beep, and that's nice. Not everybody has their buzzer hooked up, and so not everybody has the clean flight beep to help them with the syncing of the log. So if you're not running motor stop, then you can just listen for the motors to start spinning, and that's like almost exactly the moment when you armed, and so that's when black box starts. But we should be pretty close. Where's our arming beep in the log? I don't see it. That's interesting. So let's just see how we're doing here. I'm going to back it up a smidge again. So we need to bump it just a little. That seems pretty dead on. So now let's go back to 100%. Just watch the sticks for a minute and see if it feels like it lines up. So it does feel like it does feel like it's a little bit off. It feels like the stick is a little bit ahead. So I'm going to bump that forward, and we'll go back again. It's close. It's close. Yeah, I think it could still move just a little. Yeah, a lot of times the throttle also helps with the alignment more than anything else. Anyway, that feels about right. So now let's take a look back at your questions. And I've spent 5 minutes aligning your traces. Let's start by looking at your gyros. And I'm also going to look at your motors. And I'm going to zoom all the way out. Yeah, so this just my looking right here at these areas, there's a little bit of thickness here. It's not like this pencil thin line, right? There's a little bit of thickness. It's pretty thin, it's pretty clean. I like it. If you wanted to try raising your cut hertz, your gyro cut hertz, you could probably get away with it. You could definitely get away with it. What is it at? Oh, see, this isn't a full dump. Oh, it's right here. Okay, good. Gyro cut hertz is 60. Gyro LPF is 188. And that's what Boris is recommending. Yeah, if you felt like raising this, you could probably get away with it. Maybe 80. Might not go higher than 80, just off the top of my head. P term is at 40. D term is at 10. But yeah, I don't think this looks over filtered, just based on some of the traces I've seen from some of the like crazy good pilots, like Boris, for example. He posts his traces. Other sort of impressive pilots whose names you'd recognize, and they post their traces, and I look at their stuff. And this is as thin or thinner than the stuff they see. So, but it's not the thinnest I've ever seen. So I don't think it's over filtered. But if you wanted to try and squeeze a little more performance out by raising your gyro cut hertz, you probably could do it. Just again, make that one change and feel for whether you like what it did. Now, as far as your motors go, yeah, I do notice that these motors are bottoming out a lot. I don't know if that's going to be a problem. I'm not flying your copter, but anytime I see motors bottoming out, I wonder, oh, see these same two motors, which ones are those? That is your interesting. Your front motors are bottoming out. We'll take a look at that. All right, so there's your gyros. Now let's go back and let's take a look at roll. Let's take a look at roll because you asked about, is your P too low? We'll go to roll. So let's just watch your copter fly. Again, since you were nice enough to give us video, let's actually watch you fly for a minute. You got that's just the tiniest bit of bounce at the end of those. Also, notice that the copter is just slightly less responsive on pitch than on roll. I don't know if you guys could see this, but go back if you want to. On the roll, it is just sharp and snappy into the rolls, but there is just the tiniest bit of extra lag on roll when he moves the stick versus when it responds. And that probably has to do with the weight distribution. So this is one reason why guys like Warp Quad try and make their copters weight distribution more even on the pitch axis and the roll axis, try to sort of center the weight, whereas most minicopters spread the weight along the pitch axis and have it close along the roll axis. So we definitely are seeing noise here in the D term, definitely, which is amazing given how noise free your gyro traces are. Um, uh, yeah, so your filter is at your filter is at 10, and it certainly might be worth it to try and go a little lower. I can see that your copter is flying very well, and also we looked at your motor traces and they didn't look bad. So let's look for those Pac-Mans. Do we see Pac-Mans? No, I don't know, but maybe not really. So, I mean, this may be a case where trying to continue to filter the D term is a case of trying to make pretty graphs instead of just getting out there and flying. Your copter's clearly flying very well. Um, as far as your roll P goes, your rolls look really snappy to me. They look really snappy. If we look here at this, I believe this is a full roll. Yeah, it is. So if we look at this roll, your P term, this is pretty typical for what I expect to see during a roll. The P term pushes you into the roll, the gyro moves, right? Um, then it pushes so hard into the roll that then it has to reverse. And now it's trying to slow the roll down. So basically, it gave this hard shove into the roll, and then the copter started moving faster than it wanted it to, faster than was being commanded. And so it starts now opposing the roll, right? And now we get to 0 very quickly. So here's the moment where you began the roll, and that's 31.69. And here at 32.066, so roughly 4/10 of a second, I suppose, if I did my math in my head right. You know, look how long the roll is, though, right? You spend the vast majority of the roll with the P term near the axis. And what that means is that it went, get going, slow down. Okay, now we're just right. And so the P is kind of doing its thing. It seems like it's doing a good job. Um, if you're saying that when you turn P up you get oscillations, then definitely don't turn it up. This definitely doesn't look or feel to me like a quad with inadequate P gain on the roll axis. If we had inadequate P gain on the roll axis, we would see P pushing, 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 never quite getting there. It's still trying to speed you up. It would be above the line. And then as you start to center the stick, oh my God, now we're going to go down here and we're going to try and slow you down. Oh, and then you would have this horrible overshoot where it wouldn't stop in time. That's just not what we're seeing. So in this sort of off-the-cuff analysis, nothing looks too bad there. Your P on roll is just fine. Don't worry about it. Bounce back at the ends of rolls. Because your D is low, your D is relatively low, just in terms of what we usually see, 15. I would say if you have bounce back at the ends of rolls, the first thing to do is try increasing that. You're at 15, take it up to 30. Take it up to 30. Don't touch D term cut Hertz right now because it's probably fine. And don't tweak those two things. Don't tweak the roll D and the D term cut Hertz at the same time because I feel like that might be changing two things at once. Change one or change the other and see if it works better for you. But yeah, that tiny bit of bounce back at the end of the rolls probably is because your D is not high enough. Okay, I think that's it. All right, great. Woo! Got another one done. Hope it was helpful. Bye-bye.